All right, let's jump right into one of the most famous, most wonderfully weird thought experiments in all of physics. We're talking about the twin paradox. It's a puzzle that really messes with your head and forces you to question everything you think you know about time.
And it all boils down to this one simple but kind of mind-blowing question. Could two identical twins, born moments apart, actually end up being different ages? You'd think no way, right? Well, according to Einstein, the answer is a definite yes. Let's find out how.
So to set the scene, let's meet our twins, Adele and Chris. Adele's the adventurous one. She gets into a super advanced spaceship and blasts off to a star that's 12 light years away, traveling at a whopping 60% the speed of light. Meanwhile, Chris stays home on Earth, just living his life, waiting for his sister to come back.
Okay, so here's where the paradox kicks in. From Chris's point of view, on Earth, he sees his sister Adele zooming through space. He knows from Einstein's theories that moving clocks tick slower. So he's totally expecting Adele to be younger when she returns. Simple enough. But flip it around. From Adele's perspective on her ship, she's the one sitting still, and it's Earth, with Chris on it, that's speeding away from her. So she expects Chris to be the younger one. See the problem? They can't both be younger. So who's right?
To figure this out, we need to rewind all the way to 1905 and look at a couple of the strange but absolutely fundamental rules that Albert Einstein gave us with his theory of special relativity.
So rule number one is the principle of relativity. And what it basically says is that there's no special fixed spot in the universe that you can call at rest. All motion is relative. You know, if you're on a super smooth train with no windows, you couldn't do any experiment inside to prove that you're moving. As far as you're concerned, you're sitting still and the rest of the world is just flying by. Now, rule number two is the one that really bends your brain. It's called time dilation. And it means exactly what it sounds like. The faster you move through space, the slower you move through time, at least compared to someone who's standing still. And this isn't some trick with the clocks. Time itself actually stretches and slows down with speed. And you know what's so incredible? Einstein saw this coming from a mile away. In his original 1905 paper, he literally described what would happen to a clock that takes a round trip. He knew it would come back ticking slower. So what we call a paradox, for him, was just a natural, expected result of his theory.
So how do we crack this thing? Well, the solution is all about finding the one thing that isn't the same for both twins. If all motion is relative, why does one twin's point of view win out over the others?
See, the paradox is a bit of a magic trick. It makes you think that the twins' situations are perfectly symmetrical. You know, Chris sees Adele moving, Adele sees Chris moving. But that's not the whole story, not even close. Their experiences are actually completely different.
And here it is, the key to the whole puzzle: acceleration. Think about it. Adele's journey isn't just one smooth ride. To get to that distant star, she has to accelerate like crazy. Then, to come home, she has to slam on the brakes, turn her ship around, and accelerate all over again. Chris, back on Earth, doesn't feel any of that. That is the asymmetry. That's what breaks the symmetry and makes it clear that Adele is the one who really went on a journey.
And there's a really cool way to see this in action without any crazy math. Let's just think about what each twin would physically see. Imagine they each send a happy birthday message via light pulse to the other twin, once a year, every year. Well, because of something called the Doppler effect, it's the same reason an ambulance siren sounds higher when it's coming towards you and lower when it's going away. The timing of those messages is going to change. As they move apart, the signals will seem to arrive slower, and as they move together, they'll seem to arrive much faster.
And this is where it all clicks into place. Look at these diagrams. On the left, we have Adele's point of view. For her, it's perfectly balanced. She sees Chris's messages arriving slowly for the first 16 years of her trip and then sees them arriving quickly for the last 16 years, a perfect 50-50 split. But now, look at Chris's perspective on the right. It is not balanced at all. Because of how long it takes Adele's signals to travel back to him, he sees her messages arriving slowly for a massive 32 years of his life, and he only sees them speed up for the last 8 years of her trip. That huge imbalance is everything.
So if you add it all up, something amazing happens. Both twins, by counting up the slow and fast signals they received, come to the exact same conclusion. The paradox is gone. They both agree. When Adele's ship touches down on Earth, she will have aged 32 years, but her brother Chris will be 40 years old.
But physicists love to push things to the limit. They asked, okay, but what if we could get rid of that acceleration? Well, that's where things get even weirder.
So acceleration was our smoking gun. It was the thing that broke the symmetry. But what if we could design a universe where Adele could go on a round trip and meet Chris again without ever having to fire her thrusters to turn around? To do this, you have to imagine a really strange universe. Think of it like a classic video game, where you fly off the right side of the screen and reappear on the left. In physics terms, we could imagine space itself is wrapped around into a giant cylinder. The twins could start at the same spot, fly off in opposite directions at constant speeds, and boom, they'd meet up again on the other side. No acceleration needed.
So does the paradox come back to haunt us? Nope, because in this weird cylindrical universe, you get a new kind of asymmetry. This universe has a preferred frame of rest, a state of not moving relative to the curvature of space itself. So the difference between the twins isn't acceleration anymore, it's their motion relative to the very fabric of their universe.
And trust me, living in a universe like this would be wild. You could actually measure your absolute speed just by seeing how long it takes light to circle the cosmos. If you were moving, you would measure the circumference of the universe to be longer than someone standing still. Even fundamental forces like electricity would behave differently depending on how fast you were going. So in the end, the twin who stays put in that special at-rest frame is the one who experiences the most time. The traveling twin, who's moving relative to the universe itself, still experiences time dilation. So even in this bizarre scenario, the paradox is solved, just in a different way.
So what's the big lesson here? What does all this tell us? Well, the twin paradox isn't really a paradox that needs to be solved. It's more like a lesson that needs to be learned.
It's a revelation. It teaches us one of the deepest truths about our reality. There is no giant cosmic clock ticking away at the same rate for everyone in the universe. Time is relative. Your personal experience of how fast time passes depends entirely on how you're moving. The crucial takeaway is this. To make sense of the twin story, you always have to find an asymmetry. In the classic version, it's acceleration. In our weird cylinder universe, it's motion relative to the cosmos. But there is always a real physical difference between their two paths through space-time. And that leaves us with one last really profound thought to chew on. If my experience of time is different from your experience of time just because we're moving differently, does a single, universal now that applies to the whole universe even exist? The twin paradox strongly suggests that maybe it doesn't, and that reality is so much stranger and so much more wonderful than our everyday intuition can handle.